Alright, let's do a little slope review and then we'll do an application type problem as well. Because we all love to apply math. It's not just for fun. There's a purpose behind many, many types of maths and things. Alright, let's say we have a couple ordered pairs and I'm going to draw an x, y coordinate plane. Let's say we've got the point right here, and then we know that 2 points make a line. That is the truth. Let's find the slope of this line. So I'm going to jot down the ordered pairs. We got a 1, 2, and this up here is a 2, let's see here, 1, 2, 3, 4, 5. Okay, how do we figure out the slope of this line? And we aren't going to deal with coordinate geometry a ton in the construction side of things, but the concept of slope is huge, and we'll tie that in the next problem that we got here. Alrighty, so slope, it's the rise over run. Rise over run, meaning the up and down portion over the left-right horizontal portion. Okay, so a couple ways of looking at this. Well, it's been graphed, right? And we can see that we go up 3 and then over 1. So my slope is a rise of 3 over a run of 1, which means that it's just 3. That's what my slope equals. Okay? Boom. We can also do that with a formula. Say I'm not given a graph with them on there. I'm just given these ordered pairs in the context of a problem. Well, my rise would be my y coordinates, so I would do my change in y, meaning y minus y, over my change in x, so 2 minus 1. And that would give me 3 over 1, which equals 3. Voila, it's the same thing. So let's write that formula down. I'll move some of this stuff out of the way. Let's see. Ooh, yeah, I can make it smaller. That's exciting. Okay. So my slope formula is y2 minus y1 over x2 minus x1. You may remember that from Algebra 1. But that is my slope formula. Sweet! Cool. Now, let's say I wanted a line that was parallel to this existing line that we have up here. And I'm going to draw a line, that blue line. Let's say that blue line is parallel. Like, say I actually drew it well. Never intersects, right? It never touches that other line. It just runs right alongside it. What would we know about the slope? So parallel. What did that mean about the slope? The slope there. That would be the same slope. Okay. Now, what do we know about perpendicular? Perpendicular. A perpendicular line, and I'll draw this in green. A perpendicular line would do what? It would form a right angle. My goodness. Well, what would the slope of that line be? Let's see here. Well, it's kind of like the opposite direction. However, let's see here. It doesn't look to be quite as steep as the other one, right? And that's where the reciprocal comes in. And I'm going to run out of room. Kind of. Okay. Anyways, reciprocal. So opposite reciprocal. Well, what does that mean? Well, that means the slope of this green line right here, if the original line was 3, then this one's going to be negative 1/3. Okay? Means the opposite sign and the reciprocal flipped. Instead of 3 over 1, it's 1 over 3. Instead of positive, it's negative. Okay? That's a little review of parallel and perpendicular slopes. We will apply these as well in class. Okay? And in this next problem. So Jay-Z and Beyonce are building a new shed/recording studio. Okay? It will be 20 feet by 20 feet. That's the floor plan. Okay? Just a nice big old box. And have a wall height of 9 feet. And a gable-style roof. So what we're talking about is basically that classic style. You know, if you were to draw a house as a kid, that's what the roof line would look like. It's that like triangle looking type deal. Okay, so something like that. That's a gable end. And we're saying that it's 20 feet wide by 20 feet wide, right? 20 feet by 20 feet, or 20 feet wide by 20 feet long. And then it has a wall height of 9 feet. Okay, so there we go. We got our information, okay? And what you'll generally have on a gable end is you'll have a little beam going across there, right? Tie it all together so the wall doesn't slip out of place, or you might have what's called collar ties. We'll get into those things in the construction side at some point. But anyways, well, the wall height's 9 feet, but if we look there, it says if the structure can be a max of 15 feet tall, what's the max pitch of the roof? Now, pitch in construction, that's what we're using construction, is the same as slope in math. I mean the same thing, okay? So pitch is your rise over run, and in math it's slope, okay? So oftentimes what you'll hear is a roof has a 2 pitch or a 3 pitch or a 4 pitch, 5, 6, all the way up until 12, and it's always over 12, so like a 412 or a 512. They don't simplify the fractions even if you can. So what that means is if it's a 412 roof, every 12 inches it's up 4. So your rise is 4. So a 412 roof, let's write that down. 412, that means that's your rise, that's your run. Okay? So you're going to go up 4 inches for every foot, every 12 inches you go in. Okay, so let's think about this one here. What's the max pitch it can have? Because what we've got here is a restriction. And these restrictions are often based from local codes, okay? So this can be a total of 15 feet, all right? That can be a total of 15-foot height. So I basically have 6 feet to work with here because I've already got 9 feet for my wall height, right? Alrighty, well, what other factors do we have? So we're looking to say that like this can be a max. It doesn't have to be quite 6, but we're saying that can be a max of 6 feet. What's this length right here? Well, if the building's 20 feet wide, that's supposed to be in the center there. That's going to be 10 feet. Okay. Well, what do we have here? We got 6 feet and we got 10 feet. 6 feet looks like the rise. I'm going to switch colors here. 6 looks like our rise. 10 looks like our run. And we want to figure out something over 12, right? Because it's saying what's the max pitch, so it's something over 12. That's construction style terms, right? Okay. Well, I don't know what it's going to be. Holy cow. We just tied in proportions. How cool is that? We can figure out, based on our restrictions of what we need, what our pitch can be. Okay? So these numbers are a little big, so don't feel ashamed to pull out your calculator or anything like that. But we got 6 times 12, that's going to give me 72 equals 10x, and 10 is a pretty easy number to divide by, right? So x is going to equal 7.2. So essentially what we're saying here is we can go up, or our pitch can be like a max of 7.2 over 12, or why don't we round down so we're just a little bit under, and we'll say it's going to be a 712 pitch. If we look at our Swanson speed score, we'll see a 7 right there. I mean, you can get your degree and all that stuff. So, but we'll be getting into degrees and trig and stuff like that later on. But, anyways, let's recap this real quick. Our slope, right, is basically like 7 over 12. I mean, it's a little different because it was 6 over 10 to start, which is 3 over 5. But obviously some rounding happened and all that stuff. But this is a relation of slope into our construction side of things and why that slope is important. And once again, we're not going to be huge into coordinate geometry in the construction side, but it is important on the math side, as that will come up in future classes, especially in Algebra 2 and so on. Okay? Freedom.